For number 8, we have to find the length of AC. So if we look at our picture, AC is slanted, it's not horizontal or vertical where we could just count the squares. So we're actually going to have to use the distance formula in order to find that side length. So the only coordinates we need are A and C. So A is 8, 6, and C is -5, 1. So the first thing I would do is before I plug it into the formula is actually label our ordered pairs. X comes first and then Y every time for ordered pairs, and since 8, 6 I wrote it first, I'm going to give those the subscripts of 1s. For my second ordered pair, X comes first and then Y, and it gets the subscripts of 2. So I like to set up the distance formula without anything plugged in yet. I open up a long square root symbol, open up 2 parentheses. We're going to be adding those numbers inside the parentheses. We are squaring both of those and adding the subtraction signs. Now we could fill in our actual values. So in the first parenthesis, x1 is 8, x2 is -5. In the second parenthesis, we have y1, which is 6, and y2, which is 1. So this is equal to the square root of, well, in our first parenthesis, 8 minus a -5. When you have 2 negatives, you're going to add the opposite, and it makes it one big plus sign. So it's really 13 being squared, plus, in the next parenthesis, we just have 6 minus 1, which is 5, squared. So this is equal to the square root of, well, 13 squared is 169, plus 5 squared, which is 25. So this is equal to the square root of, if you add 169 and 25, you should get 194. So the length of AC is the square root of 194.